All right, now we're going to look at solving a quadratic equation using square roots. And I just wanted to remind you of what a square root is. So I have a picture here of a square, because literally when we're talking about squares and square roots, we're talking about this geometric figure. And what you notice is that the area is what is produced when you take the length and you multiply it by the width, right? So when you are thinking of square roots, you're thinking of what number is the same, just like a square, that gives me this area. So in this case, we use the example 16. And what we know about a square is that all the sides are the same. So in this case, that side would be 4. So when I take the square root of a number, I just state one side. Okay, so the square root of 16 is equal to, now this is where it's different. Last year in Algebra 1, we just really dealt with the positive outcome of a square root. This year, we're going to take that up a notch and realize that square roots have positive numbers or positive integers, and a square root also can be a negative integer. Why does that work? Well, it works because if we take the square root of 16, we know that positive 4 times positive 4 gives us positive 16. But we also know that negative 4 times negative 4 gives us positive 16. So for this reason, when we're taking the square root of a number, we can say the square root of a number is plus or minus whatever that root is. Now, what happens when we have to take the square root of a negative number? Now, this is going to be new to you. We didn't do this in Algebra 1, but what we're going to use to help us with this is imaginary numbers. Now, what you need for just this lesson, because we are going to talk about imaginary numbers at some point in this year, but what you need for now is to know that when we take imaginary squared, it is equal to negative 1. So if I want to take the square root of that, then this would be the square root of I squared is equal to the square root of negative 1. Well, the square root of I squared is just I, because I times I gives me I squared. And then that is equal again to the square root of negative 1. There is no number multiplied by itself that's ever going to give you negative 1. So for that reason, we use this I when we see a negative under the radical. So my example here is take the square root of negative 25. Well, I know what the square root of 25 is, but according to what I have here and according to what I know, 25 times negative 1 is like saying 25 times this I. So what we do is we take the square root of 25, we take the square root of negative 1, which is equal to I, and we just write that together. That's how I got the 5I. The other thing that you need to know for this lesson is how many solutions you might have. Now, if you remember in Algebra 1, when we talked about quadratics, the solutions were the x-intercepts, the roots, the zeros, the solutions. All 4 of those words were used interchangeably. So we are looking for our roots. So here, after you take the square root, if your answer is greater than 0, then that means that your quadratic will go through the x-axis twice, hence 2 real solutions. If, for chance, your solution equals 0 or a equals 0, or once you get done doing your square root it equals 0, then what that means is that your x-intercept is repeated. So it only hits the x-axis once and it bounces off. Now, this is where it's different. If your answer, after you take your square root, is less than 0, then what we've got is 2 imaginary solutions, or I call them complex numbers, imaginary numbers. Those are the same thing. And what that means is that your quadratic is hanging out in a quadrant. So it can hang out in quadrant 1, 2, 3, or 4, but it doesn't touch the x-axis at all. So we're going to go ahead and take a look at how to calculate these. Alright, let's go ahead and look at some examples. We have y squared is equal to 16, and on every single question we're always going to write our answer in simplified or rationalized form. So y squared equals 16, you just take the square root of each side. So y squared equals 16, take the square root of each side, therefore y is equal to either 4 or negative 4. And we have u squared is equal to negative 16. Now if you remember, I told you that when we see the negative, that basically that is I. So we take the square root of both sides, and what happens is this I comes out, and then I'll just go ahead and do it. So it's the square root of negative 1 and the square root of 16, because remember that negative 1 is I. So we've got u is equal to 4i or negative 4i. Here we've got r squared is equal to negative 11. I think I printed this wrong. This I is not supposed to be here. So let's cross that out. And we've got to take the square root of both sides. It's r is equal to the square root of 11 multiplied by the square root of negative 1. So that's where that I came from. So our answer would be r is equal to I times the square root of 11 or negative I times the square root of 11. We've got t squared equals negative 81. So again, we are just going to take the square root of both sides. And remember, square root t squared is t. And by now, hopefully, every time you see this negative, you just think I. So this could be broken down into the square root of negative 1 multiplied by the square root of 81. And that would give us t is equal to, well, remember this is I, and the square root of 81 is 9, so 9i or negative 9i. Now here we've got x squared is equal to 98. There's no negative, so what I need you to think about is what number could I multiply to get negative 98. So my first thought was, because it's an even number, I'm going to divide by 2. And when I do that, I get x squared is equal to the square root of 2 times the square root of 49. And I'm taking the square root on both sides. So I end up with x is equal to, well, I can definitely take the square root of 49. It's 7. So 7, I can't do anything with the square root of 2. It's this really long decimal that we don't want to mess with. So this would be x is equal to 7 root 2 or negative 7 root 2. Now here, we have the number on the same side as the variable, and we don't want that. So what we're going to do is just add 2 to both sides of the equation. And what we've got is y squared is equal to 2. Well, if you take the square root of both sides, what you end up with is y is equal to the square root of 2 or the negative square root of 2. Moving right along, we've got negative 4x squared equals 64. And again, we want x squared by itself. So first thing we're going to do is divide by negative 4. And then we've got x squared is equal to, well, 4 divided into 64 is 16. So therefore, negative 4 divided into 64 is negative 16. And we've seen something like this before, haven't we? Right here. So we're going to take the square root of both sides, and we've got x is equal to 4i or negative 4i. Here, again, we're getting q squared by itself, so we're going to divide by 50 on both sides of the equation. And we've got q squared is equal to 2 over 50. Well, if we take the square root of the denominator and the numerator, I said those backwards, I know, then we would get q is equal to the square root of 2 in the numerator. But think about 50. So we could divide that by 2, couldn't we? So we would end up with the square root of 2 times the square root of 25. Well, we know what that is. So Q would be equal to, I think I'm going to run out of room because I really didn't plan to write that much, but basically what we've got is the root of 2 divided by the root of 2. That eliminates or reduces, and so I'm left with a 1 on the top. Well, I know what the square root of 25 is. It's 5. So Q would be equal to 1/5 or negative 1/5. And then here we've got the squares on either side. So we're going to have to put all the y squares on one side and the numbers on the other. So we do that as we normally do. So I'm going to add 77y squared to both sides of the equation. And that leaves me with negative 88 is equal to 144y squared minus 81. And we're going to add 81 to both sides of the equation. And that leaves me with negative 7 is equal to 144y squared. We want y squared alone, so we're going to divide by 144. And that leaves us with y squared is equal to negative 7 over 144. But again, we're going to take the square root of that. So that would in turn leave me with y is equal to I root 7 over, well, the square root of 144 is 12. And then we also have the negative I root 7 over 12. So go ahead, try these below, and I'll be back. Alright, here are the answers for the your turn. And while I was going through, I realized that I had done all the math, but there were 2 particular questions that I really didn't answer the question, I just did the math. So here I have, what type of solutions does this equation have? Well, remember we said if a is greater than 0, we have 2 real solutions. If a is equal to 0, we have 1 real solution, and if a is less than 0, we have 2 imaginary solutions. So here, if I look at it, my answer is less than 0, so I would have 2 imaginary solutions. And for you, when you tried yours, well, a is greater than 1, so then you would have 2, let me put the correct verbiage in there, 2 real solutions. So if you have any questions, please don't hesitate to ask. I'll speak with you later.